Welcome to another episode of Learning Happy Hour. In this episode, Bob Ross comes to teach us about making happy little boxes.
And we've got a great interview with Martin Walter, who is a PM behind the new DNS Security Service. Very exciting. And Mitch explains the dangers of DNS security. The dangerous name
That's
service.
It's that time again. It's Learning Happy Hour with Mitch and Jason. BYOB and bring your own brain. Cheers.
Welcome to another episode of Learning Happy Hour. Now, Mitch and I love to learn, and we want to talk about DNS.
Dangerous DNS.
The dangerous name service. And if you've been following in our episodes before, you may have heard Tacoma Bob mention that DNS is a contributing service in like 91% of all malware attacks. That was like a study from Cisco a few years
It's also been mentioned in the Verizon Data Breach Investigation Report several times. So DNS contributes significantly towards all internet destined traffic, including malicious traffic.
Now, we've got a lot of protections in the firewall for DNS, and whether you're running 9.0 or earlier operating systems, like for one, we have this feature called DNS Sinkhole. So what I wanted to do, Mitch, to start things off is I wanted to show people, do an overview of how DNS Sinkhole works, and we were going to do a little demonstration of that as well. But what I wanted to do is invite everybody to do a whiteboard demonstration with me. So I'm going to go to the whiteboard here, but before I do that, I'm wearing my Bob Ross blue shirt. So
I saw the shirt and I'm like, he doesn't normally wear these kinds of shirts.
That's right. So I even have my Bob Ross, oops, I got to roll this up here. I got double socked, but my Bob Ross socks.
You got to get happy trees there.
This is a happy tree, right? But it gets better. I brought my Bob Ross.
Your lunch lady hair.
Lunch lady hair. This is my Bob Ross wig.
That's awesome, dude.
So let's go to the whiteboard and talk about DNS Sinkhole in the firewall.
We're going to draw with Bob Ross.
We're going to draw with Bob Ross?
I love it.
If you're not familiar with who Bob Ross is, Bob Ross did a television series and taught people how to draw paintings. This was in the late 70s, 80s, somewhere in there. So Mitch, I gave Mitch here, you've got a piece of paper. So everyone watching this, grab a piece of paper. And the point of this is I'd like you to follow along. This is the Bob Ross whiteboard hour, but it's going to be less than an hour. We're going to be talking about DNS Sinkhole. In the words of Bob Ross, let's get crazy. So we're talking about DNS security. And like any good whiteboard drawing, we need to start with a client. Now, I like to start with the square, but I'd like to go a little bit beyond that, go a little crazy.
Are we going beyond the square?
I'm going beyond the square, so we're going to have a happy client, so we're just going to draw a line right there and a C. So however you like to do it, because it's your client, as Bob Ross likes to say. So we got our client here. Now this client is not an ordinary client. This client is infected, so I'm going to draw like a symbol of infection here. I got this skull and crossbones. It's an infected client. Now, we're going to include our firewall. So we've got our happy Palo Alto Networks firewall. And the typical network, we're going to have our internal DNS server. And as Mitch pointed out, that we're going to be talking about Sinkhole, that we're referring to a solution that can help us locate our infected clients. So the problem is this. The problem we're trying to illustrate with this whiteboard is when a client wants to go out to its command and control server out on the internet. So let's draw another bad guy out there on the, so we're going to put a bad guy. This is our bad guy site. And this is going to be our C2 server. Command and Control. And then out on the internet we have external DNS, so let's just do a little rake or hierarchy DNS tree right there. So this is our external DNS. And so let's just kind of walk through this from the standpoint of the problem first. So you guys all following along? You got it there, Mitch?
I'm drawn. It's going great.
All right. Client sends a query for this C2 location. It's going to use an FQDN. So we'll call it, what's a good name? XYZ dot.
Do you want a real malicious domain?
Sure, what's a real malicious domain?
Terms-acc.com.
Terms-acc.com.
Okay, so whatever it is, we've got a malicious site out there like terms-acc.com. The client wants to connect to it, so it's going to do a typical DNS query here. The DNS server doesn't have it in its cache, so what does DNS servers do?
Forward.
You're right, so it's going to do an external query, right? So we're going to go out and we're going to reach out to this DNS solution out here, right, to our root and comm servers. Comm servers in this case. So the firewall sees this, and the firewall contains DNS signatures, and it identifies that or knows that that's a bad site, right? So we can block it at that point. And then this block gets written into our log. Now what log does it get written into?
Written into the threat log.
Threat log. Now here's the interesting thing. This sounds so far like a good thing, right? We're stopping, we're interrupting, disrupting the communication to the C2 server, but there's an additional problem here, and that is we don't know who actually is the origin of the query, because from the firewall's point of view, who is sending the query?
The DNS server.
The DNS server right here. So that's what gets recorded here in our threat log. So we got 5,000 clients, right? Now we've got to go here to try to locate this.
And you can't really go looking through your DNS server logs because I think of it as like a needle in a haystack of needles. There's just so many queries there.
So this is what we're going to solve, right? So what we're going to do is we're going to change our action to sinkhole in our rule, okay? So that instead of just blocking and recording to the threat log, we're going to take a different action, and let me use a different color. We're going to do sinkhole now. And what sinkhole does is sinkhole tells the firewall to actually reply to this query. So it's going to reply to this query with a sinkhole address. And so you configure the firewall with the sinkhole address. And Mitch will show us how to do this in a demonstration here in a little bit. I'm just going to put an IP address of X. We'll do it this way. W, X, Y, and Z, right? Whatever it is. So it could be, some sort of routable IP address. The firewall comes with a default IP address. Palo Alto Networks, we have an address you can use, but you can put some other routable address. The DNS server takes this, sees it as a response from its DNS query, and it's going to pass that IP address on to the client. The client then is going to attempt to connect to that IP address, like so. When it attempts to connect to that IP address, this is the important thing. In addition to configuring sinkhole, you also want to create a rule for that IP address. And this is the part that sometimes gets left out of the conversation when we talk about sinkhole. So you want a rule here that's going to catch traffic going to this IP address. Because you have a separate security policy rule, this is going to now record traffic that hits this rule to what log?
I think the traffic log.
The traffic log. Let me clean that up. We're going to make a bigger, happier square here. Now we're going to the traffic log, right? And this is going to be a deny rule. And now, who is going to be listed as the source of that traffic?
I think it's your skull and crossbones client there.
It's going to be the infected client. And what that means is you can simply do a query for your sinkhole address in your traffic log, and it will expose your clients. So the really neat thing about DNS Sinkhole is the ability to locate the clients. All right, so Mitch, let's see your your drawing here.
All right, well, I didn't get all my arrows in yet, but I did get the unhappy client.
I like it.
I was trying to do a fedora, but all I can do is an Abe Lincoln hat. So this is the Jason evil server, and then the context. I don't use the swooshy firewall. I use the transistor diagram, but
I like it.
Yeah.
Yeah, well done. Good. Let's do a demonstration, and Mitch, show us how to actually do the configuration.
All right. Bob Ross, thank you so much for that overview. I thought that was great. What we're looking at now is PanOS 9.0, and we're in the anti-spyware security profile. We're going to open up the strict profile. Now, these two predefined ones you cannot edit, but I'm going to just show you the contents of them, and we would clone it in the production environment and make any tweaks or edits we needed to. But just for seeing the settings, we're going to go in here and edit or view the strict.
So this is where you're going to configure Sinkhole
Exactly
and DNS
right.
protection.
Exactly right. So these security rules here, these anti-spyware rules here apply just to the anti-spyware signatures. But something that I think is kind of hidden, it's not intended to be hidden, but most people don't discover it, is this DNS signatures tab here. So it is hidden a bit inside of the anti-spyware profile. And what's new is this section right here, Palo Alto Networks DNS Security. This Palo Alto Networks network content DNS signatures has been there in older versions of PanOS, and as you said, those signatures get updated with the antivirus package every 24 hours. But the firewall can only hold 100,000 signatures, and that's not enough for all the different DNS domains out there. So what the DNS security feature does is, as a DNS request comes in, he'll compare it to first this list, and then he'll also send a copy up to the DNS security cloud servers, and then get a response back and say if a domain being requested is malicious or not. And if it is malicious, then that DNS request will get sinkholed using this address here. So sinkhole.paloaltonetworks.com. Previously, it was just an IP address, but the drawback there is malware could blacklist that IP address. So using a domain name here, we can change what address that translates to at whatever interval is necessary.
So just to be clear, that what's new in 9.0 is that additional signature source DNS security.
Correct.
Right? So it's in the cloud. We're extending and expanding our DNS protection.
Yeah, because as you guys will see, Martin's going to tell us there's so many domains out there that just keeping track of that, they might get stood up for 5 minutes. So we need to be able to detect that and block traffic to those malicious domains, especially when they're using things like domain generation algorithms and stuff like that. Because of the potential for false positives here, this behaves a little bit more like PanDB. We've even got an exceptions tab here. So if we flag a domain that you do legitimately use as malicious, if it truly is malicious, it might be, but you need to get to it for threat research purposes or whatever, you can create exceptions here to make it so that those will resolve back to the normal domain.
That's great. That's great. So going back to what we talked about earlier, you're going to create a security policy rule, and you're going to attach an anti-spyware profile, but you have the added capability to reference that DNS security source for your signatures, for your signature source.
Exactly right. And then the second rule that you said we should create to block traffic to that sinkhole, again, it uses sinkhole.paloaltonetworks.com. So come up here to the addresses section, create an FQDN, or fully qualified domain name address object, so that resolves to whatever the IP address we're sinkholing you to, and then reference that in your security rule as a destination address.
So you've got just enhanced protection as far as responding to malicious domains that get propped up. So in short order, we can detect those in a faster fashion.
Absolutely.
And you also can locate your infected clients.
Traffic log.
Bonus.
So what we do next is we interview with Martin Walter. He's the product manager over our threat intelligence services, including the new DNS Security Service.
Because usually when you just look at DNS, what you see is DNS requests come out from your DNS server. Mm-hmm. So if you look at the source IP address of that request to identify who's infected, you would think your DNS server is owned by the whole internet.
That's a bad day.
Exactly. Yeah.
So the real reason for DNS Sinkhole is to find your infected host.
Exactly. So it's policy action. And what we do with DNS security with this new functionality is provide the intelligence so customers can use this policy action on DNS traffic. Does that make sense?
To be honest, not really, yeah. So
first of all, you got to tell the device what is bad.
yes.
And if it sees something bad, it will then take the configure policy action,
Right.
which is alert, block, sinkhole.
Yep. So how do I tell the firewall what's bad?
So what we used to do in the past was, as part of the antivirus update, we provided the firewall with a list of 100,000 known bad domains.
Okay.
And essentially said, hey, look for these. And if you see these, take the configure policy action. However, we outgrew that feature a long time ago. And there's a couple of other problems with that. Like if you provide a static list to a firewall, first you have to deal with capacity issues.
Yeah.
How big can that list be that you put in the firewall? Second, you deal with the problem of how do customers update this list? And how up-to-date is that information really, and is it still effective?
Right.
A lot of malware domains we see are up for like a couple of hours, and that's it. Right? So if you download a list on a daily basis, it doesn't do anything for you.
Right.
And then, of course, there's some, what do we do about unknown command and control domains? Can we detect those? And what do we do about the means that adversaries use to still get around all of that?
Like DNS tunneling or data
Tunneling,
exfiltration.
domain generation algorithms, right? DGA is a really interesting topic. This is really like where they automate the whole process of standing up new domains that we don't know yet, so that now we can still connect. DNS tunneling is an interesting one. That's the abuse of the DNS protocol to exfiltrate and infiltrate data.
Right. And there's Linux packages and Windows packages like Iodine that do that very easily.
From an engineering perspective, it's actually pretty cool.
Yeah.
But it's obviously not.
Right. So are these the kind of things that the new service would be able to prevent?
Yes. So the new service essentially is a purely cloud-based approach, very much like PainDB.
Oh. So like URL filtering only for...
Same concept. Same concept,
DNS.
yes.
Okay.
Same concept, though the requirements are slightly different because from a latency perspective, we have to be very sensitive to keeping latency low, of course, because if you slow down DNS, you slow down everything. So got to make sure we don't slow things down, right? So user experience is still great. But in general, very much like PainDB.
Okay.
So the firewall sees a request, lets it go through, we reach out to the cloud and are like, what do we know about this so we can shut it down right now?
Now is one of our favorite times in the episode where we get to talk about something we've learned recently or are in the process of learning. So Jason, go ahead and tell us what's fresh on your mind.
Okay, great. So I love learning, and I love learning science, and there's a lot to learn about.
Not learning about science, but the science of learning?
Yes, the science of learning.
And I'm the other way around.
So one of the people that I follow, and people who know me know this, right? One of the people I follow is Dr. Carmen Simon. And I was reading a post that she put out recently that just kind of reviewed a core principle when it comes to learning. So if you create presentations, this might be of interest to you, and that is the idea behind diversity and distinctness. And that is the brain can recognize patterns after 3 or 4 instances, and after it starts recognizing patterns, then it starts to tend to kind of ignore it, and things start becoming kind of blurry and less meaningful. But that can be something of an advantage in your own slide presentations, because you can intentionally create patterns of slides that look similar to each other, and then the concept you want to be most remembered, you make it distinct from the rest of your content. Because if all the content looks exactly the same, you use the same template, she refers to that as camouflage. Your message gets camouflaged by the pattern. But if you insert the main message in a distinct way, it sets it apart. That setting apart makes it diverse. Now, some people might think, well, then I need to make every slide or every part of my presentation unique, but that's actually works against you. You want to create a pattern and then show distinction. So it's this, the way the brain works, you can convey your message using that kind of scheme. So I love learning science, and I thought that was a good thing to remember. And so for those of you who make presentations, something to think about.
You know what, as you said that, I'm going to make an analogy in mine, but I was thinking about traffic signs. You know, all of the direction signs are green, call that your very constant pattern, and then the stop signs are always red, yet somehow people still miss them. You know who you are. But I think that's kind of speaking to that, you know, that difference that's meant to jar your attention. Or yeah, that's cool. Thank you for sharing that. So mine is nerdy again. This one comes from one of my favorite threat researchers. His name's Brian Krebs. If you are unfamiliar with Krebs on security.com, check it out, because he goes to great lengths to produce quality reporting, information that is relevant and accurate. He very rarely goes out on a limb and makes conjecture and things like that. So one of the recent articles he did was a deep dive into the recent widespread DNS hijacking attacks. And you can find it on his website. And this is the first time I heard the term DNS espionage, which is apparently a big thing going on right now. And
I haven't even heard this term. This is...
Yeah, DNS espionage. Apparently, I think it was either coined by Cisco's Talos or Taos. There should be an L in there. Or CrowdStrike or DHS, one of them. And then there's this Farsight security team also who he references in his article. And it's talking about how DNS hijacking is a big threat today, and people aren't really thinking about it. Now, DNS spoofing or cache poisoning is a tactic that's been around for quite a while, and that's so that I can target a specific individual. We could do zone transfers and ways to compromise your specific DNS server. That's why you don't want unauthenticated zone transfers. But what happened recently, there was this threat actor group, and they don't give clear attribution, but they do say it's most likely either, I don't want to go into it. Read the article, because there's a few different ways you could go with that. But I do want to read one little quote from here, which I thought was pretty interesting. So he was working off of these various indicators of compromise, and then he started to do his own research into it beyond and above what the other practitioners had provided. And he says he was able to see in the last few months of 2018, hackers behind DNS espionage succeeded in compromising key components of the DNS infrastructure for more than 50 Middle Eastern companies and government agencies, including targets in Albania, Cyprus, Egypt, Iraq, Jordan, Kuwait, Lebanon, Libya, Saudi Arabia, and UAE.
That's a mouthful.
Yeah, but it's interesting that these attackers are targeting Middle Eastern companies. I could understand the government agencies and stuff like that, and a lot of the records that were compromised, as you dig into it, include mail records, OWA, mail dot, whatever.
Oh, interesting.
So they were after communications, in large part from what I can see here. And the way this works, by the way, if DNS is something that you really don't worry about, you should be worried. To use the traffic sign analogy again, when let's say you're taking a road trip, you don't have Google Maps with you or whatever, and the road sign says, turn right to go to Wally World, when really left is the direction you would go to Wally World. Then you were just completely misled, and you could be taken to a false version of Wally World. Maybe it's a Six Flags, and they're just trying to piggyback on a claim. And you would be very, very disappointed in the real world, but in computing and on the internet, you could be taken to a phishing site or a rogue mail server, and you could carry on, communications at a protracted period of time, or prolonged. Did I get that right? I don't know if I got the right verb. Prolonged period. Yeah, protracted is short. Anyway, all under the watchful eye of some malicious entity. So DNS Sec is one of the technologies out there that is supposed to be able to add integrity to DNS records, but the DNS espionage is targeting top-level domain servers and domain registrars. So not individual domain servers like Google.com's DNS server, for example. They're going to the TLD, like the .com servers, and they could compromise really all .com records and force them to one specific malicious, point. Maybe it's a proxy server, and they're just going to show you. They could compromise, as we talk about in a different episode, a certificate authority like DigiNotar, and then stand up all kinds of fake yet legitimate-looking sites. So DNS espionage, DNS security, big focus lately, and it's only going to get bigger as we talk about in this episode, so it's a focus not just for this episode, but I think it should be a huge focus for everyone going forward.
Yep.
Protect your DNS.
Well, that's great. Thank you for sharing that. I noticed that some of these domains are intelligence or police, or kind of curious what they're actually looking for, but it just points to what you said, and that is you want to keep your DNS secure. So thank you so much for watching this episode of Learning Happy Hour. As always, please leave your comments and your feedback, and more importantly, you want to make sure DNS is secure. Even if you don't have 9.0, you can still use DNS Sinkhole and have happy DNS.
That's right. Or at least sinkhole DNS if it was towards malicious.
Right.
Yeah, and the DNS security feature definitely makes the responsiveness a little bit quicker when you go to 9.0, but as Jason said, don't hesitate to dive into that anti-spyware profile, turn on DNS Sinkhole. It's a feature you already have. If you have a threat prevention license, might as well be using it.
Until next time, cheers.
Cheers.
So, okay, I'll pick it up.
Loosen the cheeks.